Hi and welcome to Maths class. In this lesson we're looking at practical applications of linear graphs. So these are those kind of worded problems where you need to work out some information and they're kind of like semi-real life contexts. So maybe the context of the problem is something real, but the problems are a bit simpler than what we would normally encounter because, these are practicing for year 9. So I know I've talked about this before. Quite often the problems we work on in school maths are they don't quite feel realistic, and that's because real life problems are very complex. So what we try and do in year 9 maths is we're learning the skills of year 9 maths, so we have to simplify the real life problems to make it doable. So also, I just want to remind you that you might be able to solve these problems sometimes without using your algebra. But what we're doing here is learning a skill which we need, which will help us to develop more and more complex skills so that eventually we'll be solving problems that cannot be solved without the use of algebra. And so for that reason, even if you think you can solve the problems given just by using logic or common sense, we're going to follow the steps and use our algebra. So, practical applications of linear graphs, we've got some steps here. Oh, I'm missing a few steps. Hang on a sec. Okay, that's better. So the first thing we do is we define our variables. Now, quite often that will be done for us, so we won't need to do this step. But if it wasn't done, I would write something like let x equal the number of shoes, if this was a question about shoes. Okay, the number of shoes. And you have to be really specific here. Do you mean the number of shoes or do you mean the number of pairs of shoes? All right, that's one of the reasons why we have to do this step and we write it out. But in a lot of the questions you'll do, this step will be done for you, but remember to do it if it's not done. Then the next step is we write a rule. Now there's lots of things we can do to help us write a rule. We can use the information in the question to make a table of values. This is where we can use our common sense. If we read the question and it makes sense to us, we can say, okay, well, if it's a question about, let's say, traveling in a taxi, if I traveled no kilometers, what would I pay? If I traveled 1 kilometer, what would I pay? If I travel 2 kilometers, what will I pay? And we can make ourselves a table of values and then use the skills from the previous video to then come up with a rule. The other thing you can do is write the information given as points. So if you know that for example, to travel 1 kilometer, I would pay $10, then I could write that as the point 110. Okay, and if, of course, once I've got 2 points, if it's a straight line, I can now find the whole rule by finding first the gradient and then using substitution to find the value of c, the y-intercept. Or the other thing I can do is I can go straight to the words. So I've got to look for what's called the constant term. And in worded questions, this is often like a fixed fee. So for example, it might be a delivery fee or a monthly fee or something like that. It's something that doesn't change. And then I need to look for the gradient. And the key to this is looking for the word per. So if I see in my taxi problem that I'm paying $3 per kilometer, then that means the 3 is going to be my gradient. And it's probably going to be multiplied by the number of kilometers. Then I have to actually answer the questions. Okay, go and look at each separate question and answer them. Sometimes that will be using the equation that I've written. I make sure I write my solutions using words. I don't need full sentences. It could be enough to simply write cost is $3. Okay, number of kilometers is 4, something like that. Then make sure you check your answers not by going back to your equation, but by going back to the original information in the question. Because if you made a mistake at step 2, this is where you might find it. Okay, if your answers actually don't meet the criteria in the original question. So I'm just going to go through one example, and in this example we're going to practice these 2 steps, looking for the constant term and the gradient in the words of the question. Okay, so a garden store charges $7 per cubic meter of soil and $30 for delivery. And I need to first of all find the rule connecting C, the total cost, with S, the number of cubic meters of soil. So in this question, C and S, my variables, are defined for me. So I don't need to do step 1. I'm going to go straight to step 2. So let's revise what we looked at. The constant term is the thing added or subtracted. It's the thing that doesn't change. And the gradient, I look for the word per. So let's look for the word per in the question. And there it is. $7 per cubic meter of soil. And see, it's per something. And this something is going to be multiplied by the gradient. So this is the gradient. And it's multiplied by cubic meters of soil, which is S. Okay? So far, I've already got C equals 7S, because 7 cubic meters of soil, $7 per cubic meter of soil tells me that for every 1 cubic meter of soil that I'm increasing, the cost will increase by $7. So if I had a table of values like this with S and C, when I go from 1 to 2 here and I add 1, my cost is going to go up by 7. So that's where the link is between this M value here, this per number, and the actual gradient. It's increasing by 1 whenever my S value, which is the equivalent of my X value, is increasing by 1. So then what's the constant thing? The thing that I add on the end? Well, it's going to be the delivery, because I'm going to pay that no matter what S is. So the constant thing, this constant term, does not change. And I'm going to say with X, but you understand, you need to understand that when I say X, I really mean whatever it is that we're looking for. That's the X value. And in this case, it's S. So this $30 doesn't change with how many cubic meters of soil I buy. If I buy half a cubic meter of soil, I'm still paying $30. If I buy 20 cubic meters of soil, I'm still paying $30. So I add 30. Okay? All right, part B. Now I'm up to step 3, answer the questions. Use the rule to calculate the cost of 7 cubic meters of soil. So all I do then is I substitute in S is 7, and I go 7 times 7 is 49 plus 30, which gives me $79. And I have to remember to write the solution using words, or I should pop in here and units. Don't forget your units. And in this case, the units will be dollars. Cost of 7 meters cubed is $79. Okay, so I didn't really write a full sentence, but there are enough words there to make it clear that this is the cost and this is what I'm paying for. Okay, part C. How many cubic meters of soil could you buy with $200? So now I know that my cost is going to be 200 and it's S that I'm looking for. So I put that into my equation, this equation over here. 200 equals 7S plus 30. And please note that in this question, you've probably got a mark already just for writing that down. Even if you haven't solved it, by putting that into your equation, you've got your mark. So 200 equals 7S plus 30. So this is now 170 equals 7S. So S is 170 divided by 7. I'm going to need my calculator at this point. So my calculator tells me that 170 divided by 7 is 24.29 something. So I write down, notice that when I wrote this, I wrote approximately equals. All right, now what I need to do is I need to think about, how do I interpret this? Is my answer 24.29? Are cubic meters of soil something that I only buy in whole numbers? So if this was, if I was buying let's say bags of soil, if it came bagged, then I could only buy a whole bag. So let's assume it comes bagged, and I'm going to write I can buy 24 cubic meters of soil. Okay, this question probably wasn't very clear at the start about how that would work. In fact, you probably could buy 24.3 cubic meters of soil if you wanted to, but generally speaking, I would imagine they would only sell it per cubic meter. So let's assume that. Okay, so I've answered the question. Now notice that I have to round this down. Now, even if this was like 24.9, it's not enough for 25, so I still have to round it down, even though 25 would have been the nearest. So when I'm paying for things and I don't have quite enough to get me up to the next one, remember that I always have to round down. Okay, so now just remember that what I have to do now is check my answers using the original information in the question. So that's definitely something that I can do for the second question. How many cubic meters of soil would you buy with 200? So let's think about that. If I've paid $200, if I've bought 24 meters cubed, let's check it. $7 per cubic meter of soil. I'm doing this on my calculator. You can't see my calculator, but what I'm doing is $7 times 24 plus $30 delivery, and it gives me $198. Now that's just under $200. Let's just check it. 7 times 25 plus 30, that gives me 205, right? It's too much. So I can't afford 25, I can afford 24. So that's how I go back and check it with the original words in the question. Okay, that's the end of this video.